Hey all, this is the Unit 3 review guide. Just so you can know before we begin that this test is going to be no calculator. You can use a 4 functions, okay, but nothing else, just a 4 function calculator that we have in class, those small ones. And we'll talk about what that looks like in a second. There's a correction to be made immediately on this number 1. This is not going to be ln, this is actually going to be log base 2. So everything will be written in a way that you can do it without a calculator, and anything that requires any complex calculations can just be left in exact form. Okay, let's begin here. So we want to graph this function, and so we're going to fill in a couple points and then graph it over here. So what points do you want to fill in? The points that you want to fill in are values that make this inside 1 or the base, okay? We want to make that 1 or the base because that's going to make it really easy for us. So what value makes that a 1? 3 makes that a 1, right? So I want to use 3, okay? Then when I plug it in, I'm going to do it over here. So if I have g of 3 is going to equal negative log 2, 1 plus 3. Remember, log of 1 always is 0 because this has to be the 0 to get that. So now I have just negative 0 plus 3, so my output would just be 3. Okay, so here I'm going to have 1, 2, 1, 2, 3, just like that. Okay. Then we want to make it its base. To make this its base, if my base is 2, I want to make that a 2. So we're going to try 4. So we do a g of 4 is going to be negative log 2 plus 3. So log 2 of 2 is just 1, because 2 to the 1 is 2. So that's negative 1 plus 3, which is 2. So 4 is 2. So I don't know why I put 0, 3 there. It's 1, 2, 3, 1, 2, 3. So this would be 3, 3, and then 4, 2. Okay. Now, also something that's going to help us is going to be this this vertical asymptote. The vertical asymptote occurs when my input here is 0. So what makes that 0? 2. So that means my vertical asymptote is going to be right here at 2. So now I can start to fill this in. There we go. So some things to remember is that log graphs have only vertical asymptotes, only a vertical asymptote, and an exponential will have only a horizontal asymptote. Okay. Find any asymptotes in the original function. So we know that my horizontal asymptote would be x equals 2 is the vertical asymptote. Okay. Let's fill in the rest of this. So what are the transformations? Well, the transformations are reflection over x-axis. We have horizontal shift 2 to the right, and we have vertical shift 3 up. Okay, so that's the upward shift is that plus 3, the minus 2 is the 2 to the right, and the negative out front is that reflection over the x-axis. Define the domain and range. So the domain is going to be from that horizontal asymptote, so from 2 to infinity, and the range is all real numbers, or negative infinity to infinity. Okay. What about the end behavior? Well, g of x approaches to, so this is where basically y is going. Y is going to negative infinity as x goes to infinity, and y approaches infinity as x goes to negative infinity. Okay, and that's just, I'm getting that from just reading the graph here. Okay, reflect it over the y-axis and find the equation. So to reflect over the y-axis, we are going to change the x inside the function negative. So this is my original negative log 2 x minus 2 plus 3. That's my original. When I reflect over the y-axis, it'll become negative log 2 negative x minus 2 plus 3. So we can just draw that reflection. Now my vertical asymptote will be at negative 2. This will be at negative 3, 3, and negative 4, 2. So it's just going to mirror it like that. Okay? Roughly. All right, that's page 1. Page 2. Leave your answers in exact form. So this is what I was talking about with a no calculator. The population of scary heights is 85,000 in 1900 and has been decreasing at a rate of 1.25% per year. Estimate the population in 1947 and then estimate when the population reached 40,000. Okay, so first we need to write our equation. So remember that this is an exponential function. Exponential functions are written like this: a times b to the x. Okay, so a is our starting value. Well, what do I start with? I start with 85,000. So my a is going to be 85,000. B is that growth rate. So it says I'm decreasing at a rate of 1.25%. That means I'm actually multiplying by 90, so 0.9875. Okay, that is actually decreasing by 1.25%. Okay, if you're increasing, remember, a will be greater than 1. If you're decreasing, a should be less than 1 but greater than 0. So that's a good hint for you. If I'm decreasing, make sure it's less than 1, right? All right, and then we're going to put that to the x. So that's my function. So what's the population in 1947? Well, that would be 47 years later than 1900. So we just say for a, we could say like a of 47 equals 85,000 times 0.9875 to the 47. And that would be fine. You don't have to do anything more than that. You just set it up, all right? For B, estimate when the population reached 40,000. So this is now solving for that t. We would say 40,000 equals 85,000.9875 to the x, some unknown. Then we would get this exponential alone. So we're going to get 40,000 divided by 85,000 equals 0.9875 to the x, right? It's divided just to get that alone. And then to undo this, we're going to take the log of 0.9875, both sides, log 0.9875. So my answer would be, when you take the log of this, this will undo that. So x will equal log 0.9875 of 40,000 divided by 85,000. And that's what you would, if you had a calculator, you would just put that in the calculator, but that would give you the number of years. Okay, continuing. Solve each equation algebraically. So we have different kinds of equations, different kinds of exponential and log equations. This first one, we are looking to make the bases the same, and if you can, you want to try and make the bases the same, and then set the powers equal to each other. So 1 over 25 is the same as 5 to the negative second, and so that's going to be 5 to the negative second to the 2x plus 1. And then 125 is the same as 5 to the third to the 3x minus 2. So on the test, like these will be pretty like straightforward. They're not gonna be any crazy big numbers, and you'll have a 4-function calculator if you're like unsure about those perfect cubes or perfect squares or whatever they might be. But they should be pretty straightforward. They will be pretty straightforward. Now I'm basically setting these equal to each other. We're gonna distribute with the power rule. 5 to the negative 4x minus 2 equals 5 to the 9x minus 6. Then we're going to set those equal to each other. Negative 4x minus 2 equals 9x minus 6. And then, so 4 equals 13x. So x equals 4 over 13. Okay? This one. We want to combine these logs together. So to combine these logs together, I can rewrite this as log 9x, log 7, minus log 7, 49 equals 0. Then I can rewrite that as log 7 9x over 49, right? That's the subtraction is division equals 0. And then I can rewrite this as an exponent. So this just means 7 to the 0 equals 9x over 49. That means 1 equals 9x over 49. That means 49 equals 9x, which means x equals 49 over 9. Okay? So you're combining those logs together, you convert it into an exponent, and then you solve for x. Okay? Let's do another one for practice. This is very similar, except this one is addition instead of multiplication. This would be log for 2x plus log for 7 to the third, which is 343, equals 3. We're adding, so we're going to multiply, so log for 686x equals 3. That means that 4 to the third equals 686x. That means that 64 equals 686x divided by 686 divided by 686. So x equals 64 over 686. Okay. So again, the numbers will be clean, and you would be able to use a 4-function calculator to do like 4 to the third or do 7 to the fourth. Okay. Last one. This is a quadratic version. So this is already like kind of simplified for us, and we're just converting it to an exponent. This is going to be 3 squared equals x squared minus 7x minus 9. That's 9 equals x squared minus 7x minus 9. We're going to set that equal to 0. So we're going to get x squared minus 7x minus 18. That means my factors are going to be x minus 9 and x plus 2. So my solutions would be x equals 9 and x equals negative 2. Okay. Now you want to go back and plug it in here to make sure it's not going to be a negative value in here. So we can test that. So when I plug in my 9, I'm going to get 81 and 63. So I know that one's going to be positive. When I plug in negative 2, I'm going to have 4 and negative 14, and negative 9 is going to be negative. So this was not going to work. So x equals 9 is my only answer. Okay, this is extraneous. All right, is that clear? So when I plug in a negative 2 in here, it comes out negative, and you can't take the log of a negative value. All right. Time for some compound interest. Aubrey invests $8,300 in an account paying an interest rate of 2.2% compounded quarterly, assuming no deposits or withdrawals are made. How much money to the nearest cent will be there after 13 years? So you just have to set up the equation. So basically we're doing A of 13 equals the principal, 8,300, times 1 plus the rate, 0.022, divided by how many times it's compounded, that's 4. times 13 times 4. That's it, guys. That's it. Nothing else. You just set it up. Okay? Christopher is going to invest $130 and leave it for 16 days, assuming the interest rate is compounded continuously. What interest rate to the nearest 1/10 of a percent would be required for Christopher to end up with $190? So this is the PERT equation, so P equals E to the RT. So, A equals P times E to the RT. Okay, so we're going to invest $130. So, and I want to end up with 190. So we're going to set 190 equal to 130 times E to the rate, which we don't know yet, times 16. Okay, and then we're going to solve this for R. So we're going to divide 190 by 130 equals E to the RT, R times 16. And then we are going to take the ln of both sides. And so that'll give us ln 190 over 130 equals R16. Because when you take ln of e to the power, that just eliminates the e part, okay? Then we're divide both sides by 16, so R would equal ln 190 over 130 over 16. And just leave it like that, okay? Last page here. So we got some more log and exponential equations. Log base 4x squared minus 2x equals log base 4 5x minus 12. So when the bases are the same, kind of like the exponential, you can just set the insides equal to each other. So this is just x squared minus 2x equals 5x minus 12. So we're going to set that equal to 0. X squared minus 7x plus 12 equals 0. So x minus 3 and x minus 4. X equals 3, x equals 4. Make sure they both work. So we have 9 minus 6, yes. 16 minus 8, yes. 15 minus 12, yes. So they both work. So because both, when I plug in both, I always get positive numbers in here. These are both going to work. Okay. This is similar, but they're not all, it's not all set equal to each other yet. We have to combine these ones first. So remember, when you add, it's the same as multiplications. This is ln x squared plus 3x equals ln 20 minus 5x. Same thing, so them equal to each other. X squared plus 3x equals 20 minus 5x. So x squared plus 8x minus 20 equals 0. So my factors would be x plus 10 and x minus 2. So my solution would be x equals negative 10 and x equals 2. But remember, you take it, you plug it back in. Look, negative 10 goes in here, not going to work. 2 will work for all the others, so 2 is my only solution. So this is not going to work. This is extraneous. All right, 2 more. Log base 4 negative x plus log base 4 6 minus x equals 2. We're going to combine these. So we get log base 4 negative 6x plus x squared equals 2. We're going to rewrite this as an exponential. So 4 squared equals negative 6x plus x squared. That's 16 equals negative 6x plus x squared. We're going to rewrite this as 0 equals x squared minus 6x minus 16. My factors then are x minus 8 and x plus 2. So my solutions are x equals 8, x equals negative 2, but 8's not going to work because this negative right here, negative 2, does work. So this is my only solution. This is extraneous. All right, last one, another exponential. Get the exponential alone, plus 3 both sides. E to the 7 plus 2x equals 3. To undo an exponential, you take the log, ln both sides, ln. So 7 plus 2x equals ln 3 minus 7. 2x equals ln 3 minus 7, divide by 2, divide by 2, x equals ln 3 minus 7 over 2. And that's it.